Today, we're climbing a truly epic ladder. We're going to start on the very first rung with a simple law of physics, and by the end, we'll be looking out at the ultimate fate of the entire cosmos and our place in it. So, let's get into it.
Right, so here's the mystery that's going to drive our whole journey. At its very core, the universe has this relentless push towards disorder, towards chaos. And yet, here we are, you and me. We're complex, ordered beings living on an incredibly complex planet inside a galaxy filled with structure. So how is any of this even possible?
To answer that, we have to start right at the bottom of our ladder, with maybe the single most fundamental law governing our universe, entropy.
So what is entropy, really? The simplest way to think about it is as a measure of disorder. Imagine pouring cream into your coffee. At first, you have two very distinct, very ordered things. You've got the black coffee, and you've got the white cream. But the moment you stir it, they mix into this one uniform brownish state. You can't unstir it, right? All that information about where each little bit of cream was, it's just gone. That irreversible slide into disorder, that's entropy in action.
And what's really fascinating here is that this idea of entropy kind of splits into two related concepts. You've got the physics version, which measures physical disorder. Then you've got the information theory version, which measures unpredictability. But you notice the common thread, right? They're both, in their own way, a measure of uncertainty. Whether you're talking about molecules in your coffee or letters in a random message, higher entropy just means less certainty, less structure.
And this really gets to the heart of it. At its core, entropy is a destructive force. Think about a book. It's a marvel of ordered, meaningful information. If you burn it, its total entropy goes through the roof. But what happens to the story? It's just gone. That beautiful information is erased and it's replaced by random ash. So the key takeaway here is this. On its own, entropy is the enemy of information.
Okay, so let's climb up to the next rung and see how this all plays out on the grandest scale you can imagine. Because this isn't just about coffee or books anymore. This is the story of the entire universe.
This timeline reveals a really incredible cosmic story. We start with this quiet, almost boring order of incredibly low entropy. Then we see this explosion of complexity, where meaningful information actually grows, before it all eventually just fades away into the silence of maximum entropy. And get this, we are living in that middle period, right now, the universe's sweet spot. It's a bit of a paradox when you think about it, isn't it? The beginning of the universe was extremely low entropy, super ordered. But it was also simple, uniform, almost featureless. It was like a perfectly blank sheet of paper. There was almost no meaningful information because there was nothing to distinguish one part from another.
But then, something amazing happens. As the universe expands and its overall entropy starts to rise, gravity begins to pull matter together, and it creates these incredible pockets of order. Galaxies, stars, planets, and eventually us. Meaningful information just explodes onto the scene. Our universe is in this wild phase where the engine of rising entropy is somehow actually powering the creation of local complexity.
But this creative phase, it can't last. In the end, entropy always wins. In the far future, all the stars will burn out, black holes will evaporate, and every structure will just dissolve into this thin, uniform soup of particles, all at the same temperature. That's heat death, maximum entropy. And with it, all the meaningful information that once defined our cosmos, it's all gone. So, as you can see, the relationship is anything but simple. Meaningful information doesn't just go down as entropy goes up. Instead, it follows this incredible arc. It rises from almost nothing, it peaks during our era of structure, and then it plummets back down to zero as entropy finally takes over completely. And this brings us right down to our scale, to the most stunning example of complexity in the entire known universe, life itself. We seem to be the ultimate exception, the ultimate defiance of this universal trend toward decay.
But here's the thing, life isn't a magic trick. It doesn't actually break the second law of thermodynamics. Nope. Instead, it brilliantly exploits it. Life can exist because it's found a way to tap into a flow of energy, an entropy gradient, kind of like a surfer riding a wave.
And here's exactly how it works. Every single living thing, from a tiny bacterium to you, follows this same three-step process. 1. We take in organized, low-entropy energy. Think sunlight for a plant, or the food you ate for lunch. 2. We use that energy to build and maintain our incredibly complex bodies, creating a little pocket of local order. And 3, in the process, we dump a much greater amount of disordered, high-entropy waste, like body heat, back into the environment. We're literally islands of order, making the ocean of chaos just a little bit bigger around us.
And this is the question that takes us all the way to the top of our ladder. We've mastered this neat little trick on a planetary scale. So what if a sufficiently advanced intelligence could apply that same exact principle to the entire cosmos?
So now we are entering the realm of cosmic engineering. This is where we stop just being passive observers of the universe's fate, and we start asking if we could one day become its architects.
So how in the world might we do it? Well, these are just a few of the pretty wild ideas that physicists have been exploring. We could, say, build Dyson spheres to capture every last drop of a star's energy, or develop computers so efficient they generate almost no waste heat at all. Some theories even suggest that an advanced intelligence could learn how to trigger new Big Bangs, seeding brand new universes.
But let's be absolutely clear here. None of this is about defeating entropy. The second law is absolute. You can't beat it. It's about becoming masters of managing it. It's about redirecting energy flows, preserving information, and extending this era of structure for as long as is physically possible. It's not about winning the war. It's about fighting a brilliant, near-eternal delaying action.
Okay, but what if just delaying isn't enough? For our final step, we have to look beyond our own universe and into the staggering possibility of a multiverse. This is where the horizon of our cosmic future just blows wide open.
You see, a lot of cosmological models today suggest that our Big Bang probably wasn't a one-time thing. Instead, they point to this process called eternal inflation, where new bubble universes are constantly budding off from a larger, eternally inflating space. Our entire cosmos could just be one bubble in an infinite cosmic sea.
And if that's true, it presents a totally radical new survival strategy. What if the goal isn't just to delay our own heat death, but to delay it long enough to actually encounter and collide with one of these other bubbles? I mean, a collision like that would be an unimaginable cataclysm, sure, but it would also inject a massive flood of new, low-entropy energy into our little patch of space-time, essentially rebooting the cosmic clock.
And suddenly, this reframes everything. The ultimate purpose might not be just to survive, it might be to act as a bridge, to carry all the hard-won information and complexity of our universe, its physical laws, all of science, all of art, across the void and into the next cosmic cycle, to make sure that not everything is lost.
And that leads us to a truly staggering thought. What if life and intelligence? What if we aren't just accidents? What if we are the universe's way of reproducing? You know, just like life uses DNA to pass information to the next generation, maybe intelligence is the cosmos' chosen method for seeding new universes with the information from the old ones.
And so we end up here, at the very top of the ladder, with this one profound question. Are we just some fleeting cosmic accident, doomed to fade away with the rest of the universe? Or are we something more? Could we be the universe itself, waking up, looking in the mirror, and taking the very first steps not just to understand its own end, but to engineer a brand new beginning?